One of the projects we started about 2 or 3 years ago was to develop and fabricate fiber sensors, and we were going to do that by taking optical fiber. Here's an optical fiber with a jacket, and then the optical fiber itself is about the thickness of a hair. Hi, I'm Joe Haus, and I'm a faculty member in the Electro-Optics program and also associated with the Electrical and Computer Engineering department and the Physics department. And I do most of my work in this lab, which is in the Science Center, and work with my students and my colleagues on various projects connected with fiber optics and with nanophotonics. We pull the fiber down to about 10 microns, so a factor of 10 smaller than it originally has. That allows us to sense what's on the surface of the fiber. The fiber is loaded into here, and there's a filament that comes up, and that filament heats up the glass, melts it, and then it goes through a very precise motion. And this is called our glass processing system, where we can taper the fibers down to as small as we want to make it. And we got to pull them out of here and then put them into some kind of holder. And this is a holder that undergraduates designed and built for us, made by 3D printing technology. So the fibers would be placed in here, a top would be put on, and then we would flow either air through here, some kind of organic compounds, or we would flow water through here. Once we have the fiber placed in here, then we go to another experiment that's set up next door to do the next parts of that experiment. When we do research, you kind of get drawn into a different world. You're working very hard on a problem that you're trying to crack. You know, I'm more of a theorist than an experimentalist. I work with experimentalists, and what I like to do is do a theory, try to create a theory, and to work a theory that is close to the experiment, where somebody can go into the lab and try out something and see whether the theory works or not. If it works, great. If it doesn't work, then you start going back to the drawing board and say, well, what did I leave out, or what's wrong with this theory? What needs to be fixed in it? So we have 6 kids. And so we're the only couple where we left the kids. So when we moved from Schenectady to Ohio, 4 of the kids were left behind. So one I gave the house to. My feeling is, of course my wife may differ on this, that once you have a couple of children, they kind of help out with the others. And our children kind of came in pairs. My big hobby is hiking. I have spent a lot of time hiking in the Adirondacks because, well, we lived there for 15 years. That's the Adirondack 46er hat, and it means that you've climbed the 46 4,000 footers in the Adirondacks. Yeah, this is a nano-sized antenna. The length of this is 100 nanometers. And it's got a little gap in here, and the gap can be changed anywhere from less than 1 nanometer, so in the angstrom level, up to a couple of them. And what we're trying to find out is the difference between the classical theory and the quantum theory. Nobody has this idea that, this is just my lab and nobody else can work here, and I'm not going to let anybody else use the lab. Everyone is very open to collaboration.